All right. Well,
Hey.
good morning, everybody. It is Jomo Stewart and crew here at the Fairbanks Economic Development Corporation. It is Tuesday, March 5th, just after 8 o'clock in the a.m., and we're here for our latest Energy for All Alaska Task Force. Here in the room, we have the lovely Miss Katie Yarrow with the Interior Gas Utility. We also have Miss Cora Killian Felt here for Fairbanks Economic Development, the brilliant Ag Director plus plus plus. And our guest today is Miss Serena Allen with AirVitalize. AirVitalize, well, I'll let you say it, but it's actually an award-winning concept. It was the winner of last year's Arctic Innovation Competition, and just last week at Juneau Economic Development Council's Innovation Summit, it got one top awards as well. So it's an innovative technology to, as this is near and dear to your heart, Mr. Mike Music, help clean up the air. And so without further ado, I will go ahead and hand it over to Miss Serena. I will say, just as a reminder, we're one screen, a little hard to check chat, a little hard to see participant lists. So if you have any questions or comments, just go ahead and throw up your hands, or not, actually don't throw up your hand, just take yourself off mute and fire away. And for Miss Serena, again, this will be a little bit new. Most of what she's been doing have been like very brief pitches at pitch competitions. And so we're going to give her the chance to do a long form deep dive into AirVitalize. So without further ado, the floor is yours, Miss Allen.
Great. Thank you so much. And thank you all for being here today. I will share my screen here. Oops. Can you all see my screen? Okay.
Yes.
All right. Awesome. Thanks for the intro, Jomo. Really nice to be here to chat with you all today. I am working on AirVitalize, where we're engineering technologies that create healthy outdoor air. So currently we work between Fairbanks, which is my full-time home, and as well as Los Angeles. Um, and we're focusing specifically on particulate matter pollution as the first form of pollution that we are going to be making less in the community. So today I'm not really here to sell anything or anything like that. We are looking to start doing pilots this summer and fall, especially out here in Fairbanks. And we want to really get feedback on the idea, on your concerns, on what you're excited about. So that way we can keep making revisions as we prepare for this and hopefully to be on the commercial market next year. Some background on the problem of particulate matter pollution. We all know it out here. It's terrible. We can breathe it in the winter when it's -40. It was really bad this year. But it actually has huge global effects. Scientists say that it causes 1 in 9 premature deaths. It expedites glacial melt from a lot of those cruise ships going by. Those black particulates coming out of their stacks are sticking to the icebergs, making them melt faster. It's increasing the acidity of rain, which then dries out these forests, making us more susceptible to wildfires, which is something we've also been experiencing out here in Alaska more as well, unfortunately. And then those wildfires are creating even more air pollution. Scientists call it the #1 environmental threat to public health, and it will take an expected 2.3 years off each of our lifetimes. Although we've been doing really great work, the borough's been doing great work and different across the country to try to reduce particulates. In 4 of the past 6 years, particulate matter pollution has actually increased in the United States, which is a trend we haven't seen since the Clean Air Act in the 70s. There's some background of kind of the global case going on and why we wanted to get involved to work on this. So as I mentioned, we work between Fairbanks and Los Angeles to create these outdoor air improvement technologies. So unfortunately, today I can't show you the actual image of our device that we have. That's because we're filing for a patent. Excuse me, a second patent. We had just, I thought we had it filed by yesterday, but some things came up, and so hopefully later today. But here you can see this is an image of the Griffith Observatory, a popular place in Los Angeles, and our device is over here on the left side. We've created a product that's about 5 cubic feet, 5 feet wide, 5 feet long, and 4 feet tall, with the goal of creating air that is 85% less polluted in a range of 2 football fields of the device. And I'll show an image on what that range looks like in a moment. Some key features of it is it's entirely filterless. We're using an ionization process. which essentially means the same effect when you rub a balloon against your head and your hair sticks, the tiny particles do the same. They jump away. So we're using that and specifically designed it for outdoor use. Uses very low electricity consumptions, somewhere between 100 to 200 watts. And so this is what the range looks like from the device itself. Give me a second to look at that. In Fairbanks, we're looking to use it for two uses. We're making a device that's more mobile here than we might do in Los Angeles, because in the winter, most people aren't outside, of course, when the air is really bad. But we did some preliminary measurements around town and found that in many of the older buildings, the air quality is almost as worse as it is outside during the day as it is inside during the days that it's heavily polluted. So we want to make a device that can turn and point towards your HVAC system where the inlet of the air is coming into your building. So that way inside your office building, your home, whatever, or large, sorry, not personal homes, but like larger residential complexes, then you can have healthier air inside as well without doing expensive retrofit activities. And then in the summer, you can turn it and we can have it in public parks, public spaces as well during wildfires. And this radius is approximately the area of 2 football fields. And then a breathable height is what we're aiming for, somewhere around 5 feet. If you have any questions, feel free to pop in. I saw someone go off mute. Yeah, go for it, Mike.
Yeah, I think that you showed a 100-meter radius. So therefore, the diameter would be 2 football fields.
Yes. From the outlet, yeah, stacking them there.
So there's a directional line, the graphic on the right, and it matches the not quite triangles in the image on the left. Is that natural airflow?
Yeah, so when the air is coming out of the device, it doesn't go straight, it'll disperse. So that's our best estimate right now. It'll look almost more like these trapezoidals. And we're doing with our initial testing this summer, trying to figure out that exact range and dispersion based on a variety of factors.
This might be a strange question. Can you define what breathable height means? Is that just like the height within clean air or?
Yeah, so we're aiming for a benchmark of around that 5 to 6 feet where people are breathing within. That's
Okay.
the goal. And that is most likely if we're working during an inversion time, the inversion creates these idyllic conditions for us to be able to move air because it's so stagnant. So we can really work on developing that breathable height. When there's not an inversion, like during the wildfires, we're not 100% certain how that will play out yet. But the goal is to try to create healthier air zones and definitely at least less polluted areas at the outlet.
Okay.
Awesome. Just writing down your questions so I can make sure to keep track. Oh, and something else on this slide. So we have discovered, we did the University of Alaska Fairbanks's customer discovery program and realized that it's not just important to have the healthy air, but to be able to show it. So we are developing this into some type of software where you'll be able to see the readings. And then also it will be able to translate it for you. So there is research based on what concentration of particulate matter causes an asthma attack. So something like this data that's showing here, if it was a really bad day and you were in that area, maybe that saves 2 asthma attacks from occurring that day. Really trying to translate it into measurable issues because sometimes it seems like almost an invisible problem. It's not all the way to, full cold fog snap. So outdoor air pollution collection is a relatively new thing, but it is being done around the world. There's a few different folks working on this, successfully working on it, many more that have attempted with technologies that are not quite efficient or make sense to use. However, these have all seen a tangible impact, but we've designed to be much different than all of them. So the first two here, the China Smog Tower and Man Plus Hummel, one huge differentiator of us from them is that we are entirely filterless. So these two devices essentially put HEPA filters in a fan. They're pulling the air through the HEPA filter, which as particles pass through a HEPA filter, it becomes less efficient because there's only so much room that it can catch things at. And it takes quite a bit more electricity typically to do that. The China Smog Tower takes up a full acre of land because it's solar powered, but they have a 100-meter high tower. And so it's impractical to install in many places. The Studio Roosgaard one is actually quite successful. The most successful of this slot uses the same filterless technology as ours, but it's not very easy to install. It's designed to be a large sculpture in the middle of a garden. It's not cost effective at all, uses much higher electricity than we do, about 8 times higher. And then on top of it, none of these have these software components that we've realized is really important.
So I just pulled up, Googled the China Smog Tower,
Mm-hmm.
and you're right, it's substantial. It's a 100-meter high tower with a big old base on the bottom. So not a terribly space efficient unit.
Yep, exactly. Yeah, it works. I mean, there is something to be said for all of these. The China Smog Tower, I believe last time I read it, says that it's helping 220,000 people in China have healthier air. And due to the density of China, that is, it's not a huge range, but it does make a big impact. I believe it says that it's $5 million to build and install and 1 million a year to maintain. So it doesn't make it cost effective enough even for a high density area like China to install more of them.
Now, will you talk about in a little more detail the filterless component? Again, you mentioned the HEPA filters. I've seen the air purification units that it's like metal slats inside of it.
Yep, exactly. So we are using, I should have put a photo in here of that, but I didn't. So our first patent that's currently pending is for this fixed plate design for ionization. And so what that does is it's creating a field where the particulates are drawn to, and then they stick to the sides of these. It's just pieces of sheet metal. Once there's about a penny's thickness of buildup on the sheets, then we clean them. To put that into some perspective, PM 2.5 is 70 to 90 times smaller than a single human hair. So once there's a penny's buildup of thickness of that, it's a significant amount of pollution that's been captured. I saw someone came off mute. Did you have a?
Yes. What do you do with the particulates once you clean them from the plates? And how do you clean it?
Yep. So we clean it. So right now we're cleaning it using a vacuuming system, and we're doing all of our cleaning in-house. In the future, we want to try to automate that to bring costs down for the customer, and they can help manage it themselves. Currently with the particulates, we have a couple different avenues we could take. Right now, we're just keeping it because, like I said, that full buildup as it even with a fully cleaned device, that amount of particulate will only amount to a couple of handfuls. So that's it. That's the difference between life and death for a dozen children. It's not a trivial amount at all. As far as storage goes, we are able to kind of just keep it. Then we're looking at turning it into other forms of revenue potentially. So the Studio Roosgaard company, they made jewelry out of the particulates they captured. We've had a bunch of different ideas of what people would want. Some people have said they would want like a chess set or something like that. So maybe turning it into things and really taking the pollution out of the air and making it something that's better in as a physical product as well.
So it can be a hazardous material, the stuff that we're actually pulling out of the air.
Yes.
Oh, yeah. Okay.
That's why we're doing all the cleaning in-house right now. We don't want anyone to be exposed to large amounts of particulates.
So when you mentioned trying to put it to market, when that happens, will that then have an implemented self-cleaning element, or will you need to hire somebody that has like a hazmat training kind of deal to clean it?
Yeah, the goal is that when it's fully in market, we'll have a self-cleaning
Okay,
element, so that way it can be done in-house. Currently, we are planning to follow a contracting model and selling to only larger customers that will
okay,
buy multiple units, and then we would take care of the maintenance. The
You
idea
provide
being
service.
we provide that as a service, correct? The idea being that we would rather start solving the problem now. As I mentioned, the cyclical nature of the air pollution problem means the earlier we can get in here, the better, and then continue to develop it so that way we have that self-cleaning as soon as possible after we're able to get something out.
okay.
I think almost of my pellet stove. It burns pretty clean. The particulates are fine. But well, theoretically, once a week, if I'm running this thing, I'm supposed to go through and empty the ash bin, which is
Yep, exactly.
could be a bit messy. It'd be nice if it had, say, little aluminum containers where the ash would go in there, and I just pull it out once a week, seal it, and throw it away.
Right, definitely.
Got it. Okay.
Cool.
Well, again, guys, I would just remind everyone, just as Mike just did, if you have any questions, want further clarification, just go ahead and take yourself off mute and fire away. Thanks.
Right. I'll go a little bit into our background then. For those who have just popped on, I'll say a quick recap here. At AirVitalize, we're working on capturing outdoor particulate matter pollution from a compact device that we've created. It's about 5 cubic feet in size, with the goal of creating 85% healthier air in a range of 2 football fields from the device. So our organization actually started in fall of 2021 through a university course that focuses on engaging with communities to engineer solutions with communities instead of for communities. And since we've started, that's really been at the heart of everything we do. We've pivoted twice to try to best meet the needs of the problem. And that led us to our current successes we've been finding in the last year when we started on this core product. We won the Arctic Innovation Competition. We just won at the Juneau Innovation Summit, as well as a variety of different competitions in the lower 48. So, like I mentioned toward the beginning, really interested in hearing the feedback that you all have and any concerns, anything you're excited for, because we're constantly looking to improve as well. The Alaskan market is a bit different than what we're doing in the lower 48, but I really want to make it a huge staple of what's going on up here. It's a difficult place to live in for sure, Fairbanks and the general Alaska, and there aren't necessarily huge industries that we found that are working to reduce air pollution in Fairbanks outside of the government's initiatives, who's really funded by the EPA. And they have every dollar allocated from the EPA. So earlier, before everyone had hopped on, Mike and I were talking, and one of his first questions was if it's approved by the EPA. Unfortunately, not yet. That's definitely one of the goals. But because we're not approved by the EPA, we can't actually be implemented by the borough as part of that air pollution control plan. It's kind of a strange area because we are an innovation and government isn't necessarily typically known for writing in innovations to their plans. That being the EPA, not Fairbanks, of course. There's some friction there. So we're looking at other industries where we can help the Alaskan air quality market. And there's really two that we've been zeroing in on and trying to learn more about. The first are those cruise industries and tourism. As I mentioned before, the black particulates coming out of these cruise ships are sticking on to the glaciers and icebergs and expediting their melt. They've implemented scrubber systems, but they're not fully effective. Similar to the people who mentioned before, the chimney retrofit device that happened before with creosote buildup and whatnot in the stacks, they have a similar problem with how efficient they can make those. But also the air quality on board a cruise ship can be compared to some of the worst cities in the world, according to some research that just came out from a university in Europe a couple, I think 6 months ago now. And so they have a strong incentive to improve for the people that are on the cruise, the environment and what they're bringing the tourists to see, and then also the Alaskan port cities who have these many boats sitting there, they're running, and they're impacting the health of their community. So although it's not necessarily Fairbanks specific, we think this is one way where we could really help out Alaskans as a whole. The second one is for energy producers. I know that the majority of these plants, it's the steam that you're seeing coming off. I just thought this was potentially the best photo to show. So energy producers do have unique problems and very strict regulations already going on for them to meet compliance for air quality. But we're looking to just really learn more about the full range of what goes into energy production, because we know it's not just these plants. It's where you're sourcing the energy from, how it's being transported, amongst other features. So looking at things like coal mines, any oil that's going on, and then also these plants as well, to try to learn about how we might be able to partner to give healthier working conditions for staff so they're able to perform better, and decrease the healthcare cost and vacation days needed from inhaling worse air. So these are the first two that we are really focusing on. And then eventually we're hoping to leverage this to get that EPA approval. So that way we can be a part of these huge non-attainment plans that Fairbanks has to make and that 37 other counties and boroughs across the country have to make. And AirVitalize written in as one of those strategies so that we can be deployed and start solving the solution on a grander scale. I'd love to hear any feedback you have about these two industries and if there's any others you think it would be worth us exploring.
Well, I'll tell you, I am curious about cruise ships. I'm assuming that, the bulk, if not almost all, are running off of some kind of diesel.
Mm-hmm.
Okay. And is it the aerodynamics of the ship that help, or making the air quality inside of them worse? Like it's a big block moving along. You would get some drag behind it. So if the smoke is coming out the stack, it might get like backdrafted into the ship itself.
Yeah, so it's not fully, it depends on a ton of factors, the wind speed, how quickly they're going, if they're at a dock or if they're out a bit and staying, bringing people in on smaller boats. So there's still a lot different factors that might relate to it. But if you're standing near, wood burning stove, for example, and it's burning for quite some time and there's air pollution coming out from it, you're going to get some of the effects if you were theoretically attached to moving under it, right, at all times. So even though it looks like here the smoke is trailing off of the ships, the particulate's dispersing the entire time that it's trailing off.
Got it. All right. Well, everybody, as we move along, I don't see my throwing up their hands, but keep your thinking caps on for use cases.
Oh, I got all kinds of thoughts, Jomo. You know I do.
Fire away.
Well, I mean, just as an offer, because I happen to be the person in charge of a 38,000 square foot building downtown, if you needed a place to like deploy one for any sorts of purposes, you should get my information from Jomo. Because as a science nerd, always happy to help people to be able to collect their data to prove the viability of their product and their purpose. But also, you mentioned earlier wildfires and then the HEPA filters. So one, I realize that it's aimed at particulates and the rest, but it would be also interesting to look to see if there was any sort of like on a healthcare side of things for when you're looking at cleaning up air, if there's any sort of effects in that way for the work that organizations, like refugee organizations or Doctors Without Borders you know, something like that, because if it's small and it's portable, where they can get cleaner air for where they're working. And I'm just like totally going just like out into like the stratosphere here. And also around here, yet again, if it's portable for when we've got the, you know, fire crews out doing their stuff, if it's portable enough to deploy something like this instead of a bunch of, you know, little air filters, to try and make it a little easier on people who have been out there living and breathing the cruft, trying to keep our town from burning down for days at a time. Yeah, I mean, they're obvious ones, but I'm trying to be helpful here. It's like I miss this part of the old jobs. So yeah.
I appreciate that. Yeah, I will definitely reach out to chat more.
I'll get your contact.
This is Mike. I'm trying to visualize this. Is this a giant vacuum cleaner that pulls particulates to your equipment?
Something like that. Sure.
So how does it work?
Sure. So there's air here, our device here, and the outlet of our device over here. So we have a fan that's pulling the air through the device. Then when it's passing through, the area before the fan is ionizing the particulates so they stick. And so then only the clean air, or not clean, but healthier air, passes through the device.
Got it. I think it makes great sense that you have it down in our breathing space rather than 100 meters high where nobody's breathing. So I think that's really a positive step. My son has a business called Solutions to Healthy Breathing, or actually, he's now Ventilation Solutions also. And he uses a system of three different types of filters. First, the filter is a rock catcher, and then it's a filter, and then it's a very heavy carbon filter after that for the VOCs. And he also uses ionization. So, and this is for inside air quality. It seems to me like this would be a good setup with a good filter inside, attached to your heat recovery ventilator, and one of these systems outside the building. And I would love to see that at all of our health facilities as well. I don't think you mentioned that. Certainly the hospital is moving in a lot of air and relying, I believe now, on filters. They may have ionization as well. Do you know that, whether they do or not?
I'm not sure right now. I think they have just the normal HVAC components of a building, but I would love to talk to some folks from the health centers as well. Yeah, maybe Jomo can connect us. I'd love to talk maybe more with you and more with your son about what he's working on.
Could you put your, excuse me, contact info in the chat?
That's a great idea. There we go. And I will also put our website, which in the next couple of days should have some photos of our actual product that's up. Oh, cool. And Rami, I also just saw your message in the chat. I will make a copy of it and respond to you.
Yeah, terribly sorry, folks. I got myself in a double book and I've been listening in and I love it. But yeah, I apologize. I hope to be off this soon if we're still going.
Cool. Yeah, I'll show you guys just oh, go ahead, Joe.
Of other technologies, like again, I think of pairings. I've seen those fans that, you know, they're bladeless fans and somehow they're charging air on one side, you know, got a positive negative pole somehow, I'm assuming is how it's working, driving air through. Again, just initially from the picture, it looks like this is kind of airflow dependent. You know, something has to bring the dirty air to the unit and then it filters it on the way, you know, past or through.
during an inversion, yes. But on something like a cruise ship, maybe not.
Oh, yeah, okay. All right. Well, guys, again, we're getting lively. So yeah, just a reminder, if you have questions, you have comments, and again, we're trying to think of use cases. And Tanya, I actually thought those were really good. Yeah, make sure you forward them along.
Definitely. Well, I think I only have a 2 or 3 more slides here. Oh, and not skip to the end. So yeah, here we go. So here's our technical progress of where we've been at. So I got this question this weekend. I've been getting it a lot. The question of will it work, or does it work as a thing? Understandable the concern. It sounds a little bit out there, outdoor air purification. It does work. We tested this past summer in partnership with a program ran through Cornell University. And we were able to take this photo I have here on the left. It's a mini version of it. We put it in a box, filled that box with incense smoke, and visually and with a technology monitor, you can see the particulates decrease from a concentration of over 1,000, maxed out my reader, down to 0.4. So very low amount of particulates. The air in the box at the end of it was healthier than the air in our lab. And we know it works. The question is just, how do we get it to this benchmark of that 85% superior air in that range? So we did some design updates in the late fall. We are currently manufacturing, so we just finished creating our full mechanical unit down in Los Angeles. Now we're working with Holiday up here to manufacture our first unit here, and working with mechanical engineering students at UAF to winterize the technology. You can't necessarily have the same things ready for a unit in LA as you need up here in Fairbanks. So we're very grateful to them for their help. And then we're trying to do the pilots this summer. So we are, and as I mentioned, we're filing our 2 additional patents right now, and then I can show all of these very exciting photos that I am upset that I cannot show you guys today.
Just so you know, Energy for Alaska Task Force meetings do not have to be a one and done. So yeah, would love to have you back around again as these patents come in, as you can give more information. Yeah, we'll bring you back around if that's okay. Just keep us informed of your progress and let us know how we can help.
Yeah, definitely. And I have a little slide just real quick showing our team as well. You guys might recognize Dr. Peter Webley from UAF, a great guy. Sorry, did someone come off mute?
Oh, I did, but then I saw Peter and I was like, oh, Peter. But no, other random thought, because yeah, as most of everybody else here, that it's the random like, oh, and this submarines. Submarines are at sea for extended periods of time with a bunch of people trapped in a can, which is why a bunch of the submariners were really confused by people were upset during like shutdown during the pandemic. But air quality in a submarine, you know, indoor air quality. Now I'm just going to be quiet again.
Tanya, it's interesting that you say that. When we were constructing the cold climate housing research facility was in 2004, when Fairbanks was surrounded by wildfire. And we contracted with a submarine designer to help us with a filtration system that would work in combination with heat recovery ventilation systems that were residential scale. And he used Kathy Cahill's lab up on campus to put together that series of filters that I described earlier. And that's when we were cleaning up the air during wildfires. That was almost clean enough for surgery with that system of filters. And so you're right on, Tanya, in terms of air quality and how a submariner has some effect on what we're doing here today.
Well, it's the trying to think of places that don't naturally have access to outside air. and a underwater boat does not. And if you can get in on that sweet DoD contracting eventually, then that's, you know, a really solid line of revenue for a business. I mean, obviously longer timeline, but still, you know, thoughts.
Definitely. Thank you. And I think that's the last of the things I had. I have our little asks here, which we kind of got to most of them. But first off, we are looking to hire a part-time electrical engineer, ideally someone who has already graduated from undergrad and has some work experience, but also an electronics technician or someone with similar skill sets. I'm not necessarily tied to someone having a degree, but more just the experience in the electronics world. So if you know of anyone that might be interested, please send them my way. I dropped my contact information in the chat, and it's also up here. We are also currently in a program that requires us to do 30 informational interviews within the next, only a month and a half now. We're a bit behind, but we'd love to talk to anyone in the cruise/maritime industry and then the oil, gas, utility industry, just for a quick 20-minute chat. We can learn more about the space and hopefully be able to get this grant that is attached to finishing those. So if anyone is available for chat, would really love a moment of your time. Happy to even do it in person out here in Fairbanks, even better. And then, as I mentioned before, we're looking for summer 2024 pilot partners to test the device and give us feedback, essentially, so that way we can start making revisions for a version 2 as well.
When you say utility industry, oil and gas utility industry, again, we have GVEA. You know, they use oil. Katie Yarrow is sitting right here. She's with gas. She's the gas utility. And of course, we have friends over at the refinery. Is that what you're talking about?
Yeah, them as well as the like coal mining industries, all of those different ranges. With all of these, I'm not an expert in oil and gas, not an expert in cruise industries. The point of this grant that we're with this program we're working with is really to just talk to folks in the space and learn. We're still very much in a phase where we are constantly learning from the community and from anyone who can chat with us.
Hey.
But yeah, Katie, I would love to chat if you're free sometime. Have a coffee.
It might be me, or I might point you to my boss, but absolutely.
Great.
Yeah. And Serena, have you talked to anybody with AITA, the Alaska ATIA, Travel Industry Association, about like getting something out in one of their newsletter blasts? Because with their cruise industry and the rest, honestly, if anybody here has ever been on a cruise, I swear nobody takes a cruise who's under the age of 70 unless they're, say, going on it with their 90-year-old grandmother. That might be a very obviously specific example. And like every day, somebody ends up being evacuated from the boat for health reasons. So between the cleaning the air up as like a good, responsible thing to do and making it healthier for people who already are in a like risky health situation, it can be a cost saver and a way for them to brag about, like, you know, we're saving the environment and we're not exposing you to as many things that will cause us to have to evacuate you from the boat. You don't really bring that part up because that's not going to make people want to take the cruise. But still, you know.
Definitely.
Yeah. But they might be able to like get you out to a broader audience. And I don't know that like whatever the resource council just renamed themselves as, I have their magazine down here on my floor in my office now that I've finally made it into my office. But you know, I mean, they're out there too. And if you get a couple more interviews through the newsletter, it's something. You know, what they send out electronically.
Awesome. Thank you for that. Yeah, I would definitely reach out to both of those.
Yeah, and if you don't get too much response, just hit me up. I can be obnoxious. I'm sure you're also not surprised.
Oh, that's all. Thank you very much.
Serena, Can you
Yeah,
speak to the dimensions and weight of this unit currently
sure.
again?
Sure. So it's 5 feet wide, 5 feet long, and 4 feet tall. It's not a perfect box like it shows in the image, but the external shape is actually what we're patenting right now. We currently have the model on wheels, the one we have down in Los Angeles, to be able to move around and be mobile. The weight with everything in it is around 300 pounds. You can take things out and move just the core, and that's around 100. And really the extra weight of the plates for ionizing it. And then it just plugs into a standard outlet. So really it's designed, if you have a little trailer goes behind your truck, you can roll it onto the ramp and take it with you, as easy as that. Or you can leave it somewhere more stationary and not have to worry about theft, for example, if you take the wheels off.
With your pilot partners, what requirements would they need to meet to be an ideal partner? Because obviously you're not putting it on top of the building if you're trying to get into breathable air, or maybe you are.
Yeah, so that's something we would really discuss on a basis per partner. So for some folks, it would involve definitely looking at their site, taking some air quality measurements. And the nice thing about a pilot partner, we'd have a contract. We wouldn't disclose anyone's air quality at their site because that's none of our business. What we will publicize at that point. Just want to make that clear. That has been a concern in the past. And then we would figure out a location that they believe is best, and we believe the technology will work the best. We would distribute some small monitors that we have to be able to see the impact. And then we would leave it there for at least a period of 24 hours, if not a couple of weeks, depending on the different abilities, and come check in on it, take different measurements, and see what the impact is. And then really the biggest request we would have for a pilot partner is to be super honest about their feedback. If they think that it's too clunky and it looks bad, or like they don't like the color of it, awesome. We really want someone who will tell us that from the get-go. We're going to be developing this software component, which I see there's a question in this chat about, and I'll address it in just a moment. But if the software doesn't make sense to you, we want to know that. If our electrician that's coming in to look at maintenance is a total meanie, we want to know that, right? Like anything that could be on the realm. So really having that availability to look at the space and do some initial measurements to find a good site, and then flexibility to have a device there for a little while with just a standard electricity outlet. And then that feedback requirement would be the three things.
And then you're looking at commercial, residential, Fairbanks, and North Pole?
Yep, we're looking all over the borough.
Good to know. Thank you.
And when we say free of charge, you've got funding to say defray the cost on the pilot partner of the electricity?
We would likely have the partner pay for the electricity cost.
Okay.
It's something we could discuss further. The reason being, we're using very minimal electricity. 100 watts is our unit down in Los Angeles. With the winterizing tech, it might be closer to 200 up here. That's our current measurements for this. And so it's so minimal that it would be almost more work to figure out the exact distribution. But if it's something that really mattered to a pilot partner, I'm sure we could try to figure something out.
Cool.
And I see two questions in the chat. So the first one is, can you speak more to the software and or the connectivity that is needed and what will be expected? Of course. So we just started working on the software component. We are a hardware company at our core, but have realized that it really matters to be able to see the difference. First off, the device doesn't require any connectivity or software to run and to create healthier air. So theoretically, let's say there's no Wi-Fi at a location, something like that. It's not a problem. The device will still run. The software component is being developed by us putting out these monitors and seeing the clean air radius or the healthier air that we're creating and what that radius is. And then we're translating it into effects that make sense. So a drop in concentration from 25 micrograms to 3 micrograms per cubic feet doesn't mean anything to most of us. Maybe it means something to me and a couple of you, but all in all, it's, it doesn't really make too much sense. The app or website would be something like the borough currently has, where it can show where these cleaner air zones are, and then also what that impact is. And we'd be measuring that impact through a platform that just came out from the World Health Organization that shows the impact of changes in air quality. I think I'm hoping I'm answering your question on the first point, Rami, there, but feel free to follow up in the chat. And the second question I see here is, how has your relationship been with the Fairbanks North Star Borough air quality wood stove replacement program / efforts? Great question. So we've been in really close contact with those folks for quite some time. Way back when we were actually looking at doing a chimney retrofit device originally, and then realized, that had been tested out here, it had failed for these reasons. And really that even if you had a retrofit device, the borough wouldn't make it okay for you to burn it would still be the same rules that you have to follow for the burn levels. And that was one of the key reasons that we pivoted to our current technology. And so we still meet with them, been meeting more with the city of Fairbanks recently. The reason that we're not engaging with them as much is because, as I kind of mentioned earlier, that EPA funding is dollar to dollar accounted for. So they really have their hands tied and in a really tough spot where if they said $2,000.53 is going towards educational materials, they have to put it just toward that. So there's not a strong reason for us to engage with them currently because they're just trying to keep the EPA standards in line.
So we're brainstorming here in the room.
Awesome.
Go ahead, lob it out.
Huh? Could they go on top of vehicles that then moved around and filtered the air as they went?
That's a good
That might be
question.
an eventual.
I mean, I understand 300 pounds, but I'm curious.
Well, I'm thinking of things like you always see the cars that have the torpedoes on the roof. Eventually this thing might not torpedo. They're storage containers.
Oh, okay. I haven't seen many torpedoes.
I was imagining like VW camper vans, and I was like, yeah.
Oh no, as soon as you said that, every Subaru. Yes.
Yeah.
Frankly, the term that keeps coming to my mind is safe spaces. As far as use cases. I think Tanya's idea about, again, depending on how deployable this is, that you're a firefighter, you've been out in the smoke and it's your break time in the field. One of these units that makes sure that you now have clean air to breathe, at least so you can get a respite. Take that concept. What's the size? Is there a maximum size of particulate? Yeah, is there a maximum size of particulate where once it's too big, it won't work based on the physics? What comes to mind is back to the DoD and safe spaces. Again, if they're out in the field, combat zone, we just went through the wars in the Middle East, dusty. There are a lot of other dry and dusty places where, a unit like this, again, being deployed, now these service members have a place where they can just go breathe clean air. But
yeah.
But Katie's idea, again, I said this to you, Serena, when you first broached this concept with me, it is airflow dependent to a large degree. And so I don't know, Katie's idea about a future configuration that can fit on top of municipal buses that they're already going to be moving around the community. And now this is just simply there. It's powered off the same power system as the bus itself. It's already got an alternator. And now this thing is cruising around cleaning the air. Katie said Lyfts and Ubers. Again, folks that are already folks that are already going to be cruising around, giving you that airflow. It's forced airflow because it's mobile.
Right. I made a note of that. Definitely going to look into it more.
I was thinking school buses. They're idling hours a day outside of our children's schools, morning and night.
Make the children be engineers.
They could be cleaning up the air that ultimately goes into our schools.
Yeah, I know they tried something like this with buses in a city in Europe, and it was kind of thrown out because that wasn't having a large enough impact. But I also know that that city doesn't face the same inversions that Fairbanks has. And so when you have that very concentrated area, it would be very easy to collect particulates during the inversions and make a bigger impact than in somewhere like they had tested it. So I'll look into that more. And yeah, maybe if anyone has connections with any of the school bus companies or drivers, people from Department of Transportation or the fire trucks, would love to chat with them.
All right. Well, we are nearing the top of the hour. This has been a great presentation, and we're loving your work. Yeah, air quality is near and dear to our hearts because it's coming right in through our lungs. Yeah.
Serena, when you drop me a note, ask about the firefighters. One of the State Fire Chiefs Association officers used to be a roommate, so I could tie you into him, and he could probably get you into more.
Awesome.
Yeah.
Great. Thank you all so much. And I'll drop my website once more in the chat. If you want to subscribe to our newsletter, it's supposed to be monthly. I haven't been doing it monthly, so you definitely won't get spammed, but you will get updates about what we're up to. And hopefully in the next couple of days, some photos of our MVP that we built down in LA.
Have you been working with the Cold Climate Housing Research Center or National Renewable Energy Lab?
We did in fall of 2022, but we haven't after we stopped working on residential applications. But if we're looking at commercial, then that would apply to them again, right?
Well, I'm thinking that building might benefit from being one of your test subjects.
Interesting. Cool. I wrote that down as well. Thank you, Mike. Great. Well, thank you all so much for your time, and thank you for putting this together, Jomo. Actually, nice luck. We happen to sit next to each other on the plane going down to the Innovation Summit. So glad we were able to chat then and again now.
Right. Well, okay, everybody. Yeah, again, Miss Serena, thank you so much. And we will be inviting you back. So please keep in touch. And again, as these things progress and more things are available for disclosure, again, we're interested to see your progress, and we're here to help. All right, everybody. We'll go ahead and stop screen share. Okay. Well, all right. Let's see. I don't have anything lined up for next week specifically, but I do have something lined up tentatively for the following week, which would be the week of March 18th, 19th, in coordination with Housing Week, speaking of CCHRC. So just keep informed or keep tuned in. I'll be sending out the notices. Well, beyond that, thanks everybody for showing up. Have a great rest of your Tuesday, a great rest of your week, and we'll see you again soon for the next Energy for All Alaska Task Force.